Welcome, ladies and gentlemen. So what I'd like to kind of do is go over a brief little summary of how to graph linear inequalities. Now, basically, when graphing linear inequalities, the main important thing I'd like to do is when you have an inequality that is in slope-intercept form, the easiest thing to do is just treat it like an integral equation. Get to the test points later. Just graph, identify the y-intercept first, plot that point, and then use the slope to be able to find the next point on your line and connect and you're good. If you have an inequality that's in standard form, again, forget about the inequality symbol, treat it like an equation in standard form, and then either solve for y, so it's in slope-intercept form, and follow that method, or plug in 0 in for x, solve for y, plug 0 in for y, solve for x, which would be plotting the x and the y intercepts, plot those points, connect, and then you're good, which we call the intercept method. Then, once you have your line graph, we need to be able to determine is the points on the graph a part of the solution or not a part of the solution. So you could always use test points and choosing a point on the graph, but the easiest thing to always do is if your inequality, your original problem, is less than or equal to or greater than or equal to, then your inequality line, boundary line is going to be solid, meaning all the points will be a part of the solution. If your original inequality is greater than or less than, that means all the points on your inequality are not going to be a part of your solution, and you're going to have a dashed line. And then, and the last thing is now we need to determine, well, what about the points above and below the line? Those points can also make our inequality true or false. So we need to choose a point that is not on the line, that is either above or below our graph. The best point to pick is 0, 0, as long as your line doesn't go through 0, as long as that's above and below. And let's say the 0, 0 is below my line. Therefore, I plug in 0 and 0 in for x and y, or whatever your test points are, plug the x and y coordinates into your inequality. If it makes the inequality true, then that means all the points that are, for instance, my test point was below the line. That means all the points below the line are true, so I'd shade below. If it was false, that means all the points below are false, and that means all the points above are true. So I'd have to shade above. And that'd be the same thing would work if I chose a test point above. If it's true, you shade. If it's false, you shade below. Some common tips and tricks. A lot of times I see students having a really hard trouble with slope. So the best thing I like to do is use slope triangle. If let's say I have a point here, and I know my slope is 3, 1, well, 3 over 1, go up 3 units and then over 1. So up 3 over 1. Create that nice slope triangle, right? And remember, a slope triangle always has to be a right triangle when you're doing that. So create a slope triangle. The next thing is, it's a tip and trick because I see a lot of students that don't do it. Use 0, 0. As long as your graph doesn't go through 0, 0, 0, 0 is going to be the easiest for you to compute as your test point. Some common mistakes. Graph the wrong slope in the y-intercept. This is a very common mistake when I have an equation like in standard form. And if I have an equation that's in the standard form, a lot of students say, oh, well, 3 is the slope. No, you've got to make sure it's in slope-intercept form before you determine the slope. That means you got to solve for y. Because if I was going to solve for y, actually, crap, that problem it does work. Let's do that then. So you got to make sure you solve. Or maybe, all right, well, they could get the slope right. But they would have got the y-intercept wrong because they just would have said 7. So the main important thing, and let's do something like this. Now, all right, there we go. So if I chose a graph like that, no, 3 is not the slope. When I solve for y, it's actually -3 divided by 2. So that's my slope. And my y-intercept is not 7. It's 7 divided by 2. And that all comes from converting from standard form to slope-intercept form. The next thing is the negative slope. This one gets a lot of students. Let's say I have a slope of -4. Well, understand that can be rewritten as -4 divided by 1, which is the same thing as -4 over 1, which is the same thing as 4 over -1. So when you have a negative symbol in front, we need to either move that negative symbol to the numerator or to the denominator. It's not going to matter. As far as your slope triangle, it doesn't matter if I go up 1 to the right or if I go down 1 to the left. It's still going to be a part of the same graph. So you just need to kind of determine where you want the negative symbol to go. It does not go on the top and the bottom. That's a big mistake because -4 divided by -1 is +4. So we can only just need to move it to the top or the bottom. And the last thing is just choosing test points. I see students choosing test points that are on the graph. I see students using test points that are difficult to use, and then they make mistakes and they graph wrong or they shade wrong. So just make sure you're using 0, 0 as long as the graph doesn't go through 0, 0, and just be careful with your arithmetic one from there. So there you go, ladies and gentlemen. That is your basic summary for graphing linear inequalities. Thanks.